Hi, my name is Akshat Raghav, and I'm going to be presenting BoilerNet, our senior design project for Team 20 for the class ECE 49022 in the spring of 2025. Our project was meant to be a mini compute cluster, but evolved in order to become a mini network attached storage that provides um, in-network compute at the edge. Our team consists of Gautam Nambiar, myself, Akshat Raghav Ravikiran, Gokul Harikrishnan, and Anish Poratur. BoilerNet is a system that's supposed to be portable. It has swappable compute workloads, and it's meant to be low power, which means that it takes less power than a normal laptop would. It's meant to be scalable, which I'm going to explain soon. And it's also meant to be throughput optimized, which I'm going to show during our demo, which is the later half of this video. This is the overall block diagram for how our system works end to end. We've provided a user interface for people to, choose the files that they want to work with and do any of the normal operations that you'd be able to do in a NAS system, as well as compute, which is the main part of this project. And the backend layer is something that we have made that can, interface with different clients, and it has a multi-priority scheduler that will talk between all the users and schedule the work to different systems that we have. But right now, for purposes of this project, we've only been able to make a single system, and everything that you see in the pink is what our system is. We have three different layers of abstraction, and we've colored them separately for the video. The green nodes present here are called compute nodes. They are where the deep learning models are located, and they do some kind of inference on the images that we send through. It's basic classification right now. You can choose each of those nodes can choose, one object out of five possible objects from different sets of the ImageNet dataset. Like for example, one of them can choose between different kinds of cats. One of them can choose different kinds of dogs. One of them can choose different kind of kitchen utensils. We will see that soon enough. And then the switch nodes are the red color nodes. They are responsible for sending the data into these compute nodes as well as aggregating the results back from each of them. It's a kind of scheduler. But at the same time, it is also responsible for storing the data that comes in from the network node. And the network node is the blue node, blue color node here, which is which connects to the an Ethernet card that is connected to one of the routers that we have. And its main goal is to provide another layer of abstraction just to ensure low latency responses into the backend. And so our entire system is fully enclosed within all the nodes that sits within the box. This is to ensure that there's not much of control logic that needs to happen from the backend side. And this also enables our scalability, which means that you can have multiple of these systems attached to one router, and you can have multiple of these routers and just expose those IPs into the backend layer that we have, and you can schedule as many other jobs that you need. So that is the horizontal scalability, but we are also able to provide a vertical scalability, which is how this system itself is designed. It's all the communication here happens on the basis of SPI internally and Ethernet protocols externally. So all the green nodes are hot swappable, as we explained before, which just means that each of the nodes that you have, you can personally edit them, put whatever model you want on them, and just slot them back into the BoilerNet box. And the switch nodes are fault tolerant. The software is built in a way to ensure that if something doesn't work right, or you pull out one of the nodes by mistake, whatever the situation, there are no failures that happen that doesn't cascade the entire system. And you can swap this with anything that you personally would want. You can make your own PCB and put your own SoC on there. It is a lot more powerful as long as it can sit on the SPI bus and have just the very basic protocols of like just a few handshakes that we have set up. As long as you can do that, you can just plug and play any kind of board that you have. So this is the mechanical design of how our system looks. The right-hand side is a completely assembled box. The left-hand side shows you the timeline of how we've managed to build the system over time. All the yellow boxes are the enclosures for the small rectangular compute nodes that you see in the third image. I'm going to point at it with my mouse. So each of these boards run a deep learning model on the ESP32 rover modules, and the main board here is the main backplane of the BoilerNet system. It has these two switch nodes, one compute node, which are based out of the rover and the room modules. And we have all I have slots in order to put in all the compute nodes and a slot for any Ethernet board that you want to use. We have chosen the LAN 8720 because it was the cheapest we had, but you can use any other board you want and just change the software that's on the network node to interface. So you can slot them all into the box as you see below. And so we also provide like a open close enclosure, which is a black box. So this is just to enable you to remove the micro SD cards which we're using for storage. If you'd like, you can also put in another like much more larger micro SD card into those slots, and the system works exactly the same. So this is overall just a very quick and very brief overview of what we've built. We are going to, the next half of the video, show you how the system works.
Cool. Now, so before we start the actual demo of BoilerNet itself, I'd like to give a quick brief on the physical aspects of the box and how you set it up. So, well, right now we have a router here, and we have the box itself. So this is how it looks when the lid is closed. But for the purpose of the demo, I'm going to open it up. So this is how all the back plane looks like, and we have a few compute boards set up. You can see that we have a slot for for these compute boards, but for specifically a demo purpose, I'm going to just keep 2 and 3 to show fault tolerance. And so now we have, as we had mentioned before, a network node here which talks to the Ethernet card, and you have two internal switch nodes present here, and you have the rest of all the compute nodes. This Ethernet board can be replaced with any other kind of board that you like. We currently only have the LAN 8720 on hand, so we have set up the software to work with it, but you can configure it as you'd like. Then you have the internal switch nodes, which are rover boards, and they are connected to one micro SD card each, mainly for the storage. Right now we just had the 32 GB versions, which was the cheapest we could find at Target, and we have one micro SD card attached to the network node in order to maintain information about the directory mapping of where data is stored, in which way is it stored and whatnot. So we have a barrel jack connection here through this adapter, which is in charge of powering the entire board on. So all I'm going to do is plug it in like this, and we have a reset pin set up over here, which has a port outside here, and all we have to do is take some kind of screwdriver and try to reset it. You can see that the green light here has switched on, and that also shows us, and this one single reset pin is connected to all of the nodes here. And now what I'm going to do is take an Ethernet cable, and I'm going to connect it one to my router, and the other one gets connected to the our BoilerNet system. And if you can see here, the the yellow light has switched on, which means there has been a successful handshake between the router and the BoilerNet system, and it's been assigned an IP dynamically with the router's DHCP master. And now I'm going to reset all of the compute blades. This is a process that you have to do every time you put in a compute. And also we have this USB cable specifically for debugging purposes, but that's purely because we burnt off our USB header here. But we have the same, we have provision for the USB headers here and here, and ports where you can connect a USB cable to check what the problem is. I think so. Now that's probably all about the entire setup. If you'd like to click and close the box, but we're going to keep it open to show you exactly with some of our LED lights how the functionality works. Okay, so now we're going to show you how the BoilerNet system interacts with our backend, and we expose some basic operations like storing data, fetching data, compute, registering a job for compute, polling to check if the compute is done, and delete. And if you see my laptop screen right now, I have two images pulled up. They're just, sample images that we generated through ChatGPT, because each of these compute nodes are running different models. Like one is running for identifying kitchen appliances, one is identifying, desktop appliances, one is identifying, different like fruits. And we're going to show you that in a quick second. So if you see, our input folder is where the images are stored, and our results folder is currently empty. We'll show you that, we'll show you why that's important in a second. Now, we're gonna first begin with a store operation. When I hit store, you're gonna notice that this LED light switches on, so data is being stored in that SD card right now. When I hit the other one, the data gets stored into that way. We just have a dynamic system that's set up, which is coordinated by here, and it is preserved. The information about where data is stored is preserved here. And you'll also notice that our throughput is pretty bad, which is about like 12 kilobytes per second. But that's purely because we're limited by our read-write speeds on the micro SD cards, which are I don't even know which company it is. It's a $6 SD card from China, which we bought in bulk. But if you get an SD like a SanDisk micro SD card, you're probably going to get much better read-write speeds. So now I'm going to try doing a fetch operation, which just basically reads data from here, puts it back onto the laptop. So when I hit that, you're going to notice that that LED light switches on, our Ethernet card is flickering, and if you see on my monitor screen, on my results section, there has been an image that's brought back, and you're going to see that it's a little compressed, but that's because we're manually compressing it to fit onto these, the BoilerNet model that's running here. But that's just for demo purposes. And when I do it for the other image as well, you're going to see that the other LED light switches on and data is getting sent back. To confirm, you also see this one worked as well. So now I'm going to try doing a compute operation, and this compute operation basically registers a job with one of these internal switches, which then starts coordinating data sending and aggregation. I'm going to hold it here to show you that we're able to allow concurrency, which means both ways can be utilized at the same time, even though there's only a single port opened into the BoilerNet system. So the job is registered there. I'm going to hit the other one, and job is registered there. Data is being sent over, and both of these ways are currently in compute. So that this one just completed, and that one's going to complete pretty soon. And now I'm gonna go ahead and show you how we're going to check if the job is completed on the backend side. All I'm going to do is a compute poll, which checks if this thing is done. We say compute is complete. We're going to check it on the other side as well. Here it says it's in progress, but we're going to hit it once more, and yeah, now it says it's complete. And so basically all the data is, whatever results have been aggregated back is stored in a results .txt file. I'm going to try pulling that. And now great, you're able to see that in our monitors, in our laptop, we have two different result files. I'm going to open them up, and boom, you see that we have stuff like monitor, banana, mixing bowl, a fry pan, and desk. This basically is to show that we're able to identify some images, but also some of our scores are not really good. That's a quantization problem. We've trained our models pretty well, but we didn't go super far with it. And if you also noticed, because I don't have one of the ways set in here, it says that it's failed. I've configured the system to only recognize 3 of these. So since one is missing here, it just recognizes that okay, there's a failure, and just ignores it. So that summarizes primarily most of the things that you can do. But I'd also like to show that so I'm gonna switch off the system. Power is off. I have my battle jack here. The adapter. I'm gonna plug it back in, and I'm gonna do you know, a reset, switched on again. We're gonna wait for it to register. It's registered, and I'm gonna try to do a read operation to just check if the data that we had stored is still there, the persistence of the data. And great, well, the data is back. So this shows that all the entire system works as we have described in the report, and it's modularizable as outlined in our readme.